Okay, it's given that the acceleration of the particle is minus 13.5 for the positive value of t at which v is 0. Find k, and hence find the total distance travelled in the first 2 seconds. Well, find k. Well, we need a formula for acceleration. Okay, well, we've got velocity. So acceleration is just rate of change of velocity. So acceleration is just dv by dt, the rate of change of velocity. Okay, so A is dv by dt, which equals k 6t minus 6t squared. Okay, so we got a formula for acceleration against time. So we want to know when the acceleration is negative 13.5, we want to find out the positive value of t. But we've got another unknown. Okay, so we need to work out k, so we need to know what t is. Okay, so we know that we're interested when the acceleration is minus 13.5, we need to work out what t is, and then we can put it in this equation. So we need to go back to our velocity equation, okay, and then sub in v as 0 and see what t is. Okay, when v is 0, okay, we're subbing it into here. 0 is k, open brackets 3t squared minus 2t cubed. Well, let's factorise this. So what can we take out? We can take out t squared. Okay, we're left with 3 minus 2t. Okay, so we can see for this to be 0, it will happen when t is 0, because 0 times anything is 0, but we know that already. We know that it starts from rest. But also when this is 0, so when 3 minus 2t is 0. So 3 minus 2t equals 0. So 3 equals 2t. So t equals 3 over 2. So we can go back to this equation here. So we can sub in a for minus 13.5 and t for 3 over 2 and solve for k. Okay, I've subbed in a for minus 13.5 and t for 3 over 2. Okay, so I end up with minus 13.5 equals k 9 minus 27 over 2. Therefore, k is minus 13.5 over minus 9 over 2. So k is 3. Right, the next part, find the total distance travelled in the first 2 seconds. Be careful, it's asking for total distance, not displacement. Okay, so that means if you have a positive distance or positive displacement followed by a negative displacement, that's just counted as one positive distance. Okay, now if it's asking for the total displacement, it will be much easier. We can just go straight to the displacement equation and just use that. But because it's not displacing, it's distance, we've got to be very, very careful. Right, going back to our displacement equation, we can sub in k as 3. Okay, I've subbed in k as 3, so there's our displacement equation. Now, as I said before, you can't just sub in t as 2 in here because you will get displacement. We want distance, not displacement. Okay, here's our velocity equation, and I've subbed in k is 3 here. Okay, so let's think about its velocity. It starts off with velocity is 0, and we know the velocity is 0 again when t is 3 over 2. So that's when it changes direction. Okay, so it starts off at 0, it accelerates, and then at this point here, the time is 3 over 2, so it's about to change direction. Okay, so it carries on like that. Okay, so the particle is making progress and going forwards. Okay, the displacement's getting further and further away. Okay, and then now it's going backwards, so it's returning back to its old position. Okay, so we've got to calculate the displacement here. Okay, and then we can separately count the displacement here. Okay, so this displacement is positive. Okay, the area under the graph is positive, and this displacement, the area under the graph, is negative. So positive and negative. So if we work out the total displacement, we're going to have this minus this, but we don't want that, because we've got this distance, and then a distance is modulus is always positive. So we've got to work out this displacement and subtract this negative displacement. So we end up with positive minus a minus displacement. So effectively we're adding up the two areas in here. Okay, so we want the area under this graph. Well, it's the integral of v between 0 and 3 over 2. Well, there is the integral of v, it's s, we've already integrated it. Okay, so this area, or this distance, or this displacement is that. Okay, it's the integral of this curve between 3 over 2 and 0, which is that. Okay, now we also want this area, we want it positively. So we subtract the integral of that same function okay, and that's between 2 and 3 over 2. Okay, so I've subbed in 3 over 2 in here, minus subbing in 0, which is just 0, minus, right, subbing in 2 here, minus subbing in 3 over 2 here, okay, and that all comes to, right, incidentally, this bit is going to be 0 anyway, because when you sub in 2 in here, by doing that, you're calculating the area to the left of 2. So you're calculating this displacement from 2 to 0, which is 0. We know when t is 2, the displacement is 0. Okay, so in other words, this area is the same as that area. Okay, not the integral. The integral of that is negative. The integral of that is positive. So this bit's going to be 0. Okay, and if you calculate that, you'll confirm it. Okay, so let's do it then. So S equals, well, this first bit of brackets will be 2.53125. Okay, minus, open brackets, well, this bit is 0, minus, well, that bit is 2.53125. Okay, so altogether we end up with 5.06 meters. I mean, you could have, if you'd been smart, you could have just known that it's double that, 2.53125 times 2.